Righto, another circuit question. It's from practice exam, question 1 on page 269. Student sets up this circuit. It's got some series and some parallel components to it. She adjusts the voltage here, the power supply, until there's a current of 6 amps. So we don't know the voltage. First part of the question, the effective resistance of the circuit. So in other words, what's the resistance of all these resistors added together? And then what's the potential difference? What's the voltage across this 3 ohm resistor here at the bottom? So I need to collapse it down. The first thing I'm going to do, ignore that, which is wrong. First thing I'm going to do, these two here follow each other one after the other. It's a little series component in the circuit. So I'm going to replace that with a single 8 ohm. So that's for the series, remember, total R equals R1 plus R2. All right, that's what I've done there. So I've just added those two together to get 8. Righto, so that means I have actually got a circuit that looks like blurs. Good blurry circuit. Move it over to the side. I've got 4, 8, and 3 ohms. Right, so now I can see that I've got 8 and 3 in parallel to that 4. So I'm going to use the parallel rule. 1 on R equals 1 on R1 plus 1 on R2. 1 on 8 plus 1 on 3. And when I work that out and get the reciprocal of it, it comes, I'm just going to stick with 2. I'm not going to keep all the decimal places because later on it works out super neat if I don't do it. It's at 2.1 or something, so I'm just going to drop it off. Righto, so here we go. Resistance of that bit is 2. So that's, I could replace that with that, so that I would just have a really simple circuit with a 4 and 2. Right, so resistance is R1 plus R2. So the total resistance is 4 plus 2. It is 6. So that's part A. That's the total effective resistance of the circuit is 6. Righto, so now we need to know the voltage here. And to get that, we're going to work out the voltage for the whole circuit, work out how much gets used up in the 4, and then whatever's left is going to be used up by this parallel part. And remember, the voltage is the same across all the parallel parts. So the voltage across here is the same as the voltage across here. So that's the easiest way to do it. So we have got a total resistance. This is for part B. Total resistance of the circuit was 6 ohms. The current that she measured for the circuit is 6 amps. V equals IR, 6 by 6, so the voltage is 36. So the voltage that's being put out by the power supply is 36 volts. Right? So 36 volts of potential energy. Some of it is going to get used up here. How much is going to get used up in the 4 ohm resistor? Let's have a look. So the resistance is 4 ohms. The current, we know, was 6 amps. So the voltage across the 4, this will be across the 4. This is how much energy is getting used up in the 4 ohm, is going to be IR. It's going to be 6 times 4 24 volts. All right, so 24 volts is going to get used up here. How much is left then to be used up in the parallel part? So then we've just got 36 minus 24 equals 12. Right, so in the parallel, it's going to be 12 volts. So if I put a voltmeter in here, it's going to read 12.